Hey, algebra, welcome back. You survived week 1, you're now into week 2. I've changed the way I've labeled some things a little bit. I'm not going to start calling it algebra week 2 Monday, week 2 Tuesday, week 2 Wednesday, so on and so forth, so that you know what day you should be doing a lesson and when it is due. It's due on the day it's labeled. Now, if you are working from home and you're bored and you want to do more than one day at a time, please do. It'll help the end of my week go a little bit smoother. Just try to give me a little bit of space in between so I can give you some feedback on each assignment. So in case something goes wrong, I can try to get you some help. So, try to do one, wait a couple hours, do another, or send me an email and say, how'd I do on that? Can you check it so I can go to the next one? I will gladly react and give you some feedback right away. All right, week 2, we are undoing all the work that we did last week. That's exactly what's happening, as silly as it sounds. Have a paper, pencil, write down what I've got, hit a pause, and then be ready back to join me. I want you to remember that last week we were doing some multiplying and we were doing some distribution through that multiplication. So a recall problem, just a simple distribute. 3x times x, remember those ones that were in there? 3x times x is 3x squared. And then 3x times 4 leaves you with 12x. We couldn't put them together. They were not like terms. Don't try it. I know sometimes it's tempting to say, I just want to put them all together. Don't. All right? Today what we're doing is we're taking a look at it and saying, what can I pull out of both terms to make it look like the distributive property is going to happen? So what goes into 3 that also goes into 12? And hopefully there's a few people out there who are interacting with me even though we're not together and saying, oh, Mrs. Howard, 3 goes into 3 and 12. You're right. So I can pull a 3 out of both of those. What goes into x squared that goes into x? And we haven't talked about it a whole lot. That's what we're doing today. But you can always pull out the lowest exponent. So between x squared and x, my lowest exponent is that x to the first here. So I can pull out an x. And then when I distributed, I used multiplication. So when I undistribute or factor it, what's the opposite of multiplication? Division. So I divide both terms by that 3x. And 3 divided by 3 leaves me with 1. X squared divided by x. I would end up reducing that x. It's like I had x squared and I took 1 away, so I'm just left with x. And then 12x divided by 3x. Hey, look, those x's are gone. 5 divided by 5 is 1, 10 divided by 10 is 1, x divided by x is 1. They all end up canceling. And 12 divided by 3 is 4. Hey, look, we're right back where we wanted. So we were distributing last week, and this week we're going to factor and undo all of that work. Okay? So some examples. 5v to the 5th plus 10v to the 3rd. What goes into 5 that goes into 10? Hopefully you agree it's 5. What's the lowest exponent between v to the 5th and v to the 3rd? v to the 3rd is the lowest. If we're undoing that multiplication, we're going to divide. So I write the division underneath each one just to help me keep my head straight with that. So 5 divided by 5 is 1. V to the 5th divided by v to the 3rd. Oh, if I had 5 v's and I take 3 of them away, I'm left with 2. So v to the 2nd. Plus 10 divided by 5 is 2. My cat just knocked something down the stairs. And v cubed divided by v cubed, hey, they're exactly the same, so they cancel. So you're left with 5v cubed times 1v squared plus 2. If you want to check, not a bad idea. Distribute it and see if it would bring you back to that original expression that we had. We'll call that example 1. Let's take a look at example 2. 3x squared minus 18. What goes into both 3 and 18? 3 is right. What goes into x squared and, oh, this guy doesn't have any x's. Well, if he doesn't have any x's, I can't take any x's away. So 3 is the only part of my GCF that I can do. 3's cancel. All I'm left with is x squared. 18 divided by 3, 6. 3 times x squared, 3x squared. 3 times negative 6, negative 18. Look at that. Example 3. All right, it's a triple error. Trinomial. What goes into 4, 2, and 6? Oh, they're all even, so let's pull a 2 out. X cubed, x squared, and x. Lowest exponent, 3, 2, or 1. Lowest exponent is x to the first. I'm going to make a little note there that it's always the lowest exponent. It's important to write that stuff down so when you're doing your homework, you look back and it can jog your memory. All right, I'm going to undo the multiplication, so I'm going to distribute the division of everything. 4 divided by 2, x cubed divided by x to the first. In other words, what's 3 minus 1? 2 divided by 2, x squared divided by x to the first. What's 2 minus 1? And 6 divided by 2. And the x's are exactly the same. X to the first divided by x to the first cancels it out. All right, if you need to take a second, do so, hit a pause, and then rejoin me for example 4. (8x squared minus 12x). What goes into 8 that goes into 12? 4. X squared and x. Lowest exponent again, looks like x to the first. By the way, you do not have to put that 1 on the x if you can handle it without, but I find it helpful, so you may as well. 8 divided by 4. X squared divided by x to the first, or what's 2 minus 1? So x to the 1. 2 minus 1 being 1. 12 divided by 4. And those x's are exactly the same, so they are gone. Now what happens if I have a lot of letters going on? Because that could happen. So let's change gears and let's work with A's and B's. All right, take it separately. What goes into 13 and 39? You're right if you said 13. Take the A's separate from the B's. So what's the lowest exponent between a to the first and a to the second? A to the first. What's the lowest exponent between b to the third and b to the fourth? B to the third. And there are no other letters. But what if I threw a C in here? I'm going to do it. Can I pull a C out if one of them has it and the other doesn't? No, it's called greatest common factor because I want them to be in common. I want a factor that they have in common together. So I can't pull out a C. I'm still going to write that underneath each of them. I do not need that plus sign. That was just for fun. So that I can see that division. If I don't see it, sometimes my brain gets fuddled. 13 divided by 13 is 1. A to the first, a to the first. B to the third, b to the third. Oh dear. And then 39 divided by 13, keep your plus. A squared, a to the first, subtract those exponents. What's 2 minus 1? A to the first. B to the, what's 4 minus 3? Another 1. And then the C doesn't change at all because we couldn't pull anything out, so he's stuck. Close your parentheses. And if you feel like those ones as exponents are messy, you can rewrite it like that. I don't care what you do. Whatever you're comfortable with, whatever guarantees that you're going to get this right. The only situation I haven't talked about is what if everything in your last term cancels, but it would be just like this. You'd just be left with 1. So example 6, 4a squared plus 4a. Or how about just a? Let's just do a. GCF of both. What goes into 4 and 1? I mean 1, but we don't have to worry about that. What goes into a squared and a? A. Lowest exponent, 2 or 1. So I'm going to divide both of them by a. And when I do so, 4a divided by a squared divided by a to the first is that a to the first again. And a divided by a, if it cancels, but I have to have that placeholder. If everything disappears, what is a divided by a? Or the coefficients there, what's 1 divided by 1? Aha. So if everything cancels, make sure you get that 1 in its place. If I started with 2 terms, then in parentheses I must have 2 terms as well. Otherwise, I wouldn't have anything to distribute. And all of these should look like distribution. All right, go into your homework assignments. We're on week 2 Monday assignment. And check it out. Attach it to the assignment for me, and I will get back to you as soon as I get in there. All right. Hope all is well. Take care of yourselves.